Hi, I'm Dan Scarfe, I'm CEO of .NET Solutions, and I'm here today to talk about Scrumwall, which is our Azure-based application for doing Agile project management. So we're big fans of Agile and Scrum in particular, because we feel it's an excellent way to deliver software projects on time and on budget. Anyone familiar with Scrum will know a central part of it is the project wall, which traditionally is just a series of post-it notes stuck on the wall, and you move those post-it notes around to signify how you're doing on your actual project. The problem with the traditional Scrum wall is if you've got off-site developers, if you've got customers who can't come into your office, it's very difficult to all gather around the Scrum wall and see what the progress is. So we developed an application internally to allow us to manage that on an electronic basis and have multiple people around the world connect up and see the Scrum wall and make changes to it in real time. Customers saw it and they liked it, and some of the other development companies that we partner with also liked it. So we thought, well, hey, wouldn't it be great if we could actually build this on top of Windows Azure so that we can scale it out to hundreds or even thousands of users. So we're just going to go right ahead and show you a demo of this application to give you a flavour of what we've created. We're immediately presented on the left-hand side with a list of all of the projects that we're currently managing. But what we'll do is we'll just go ahead and create a new project. So we click up in the toolbar. We can go in, we can just enter a project name and various other information such as who's the sponsor and the description. So we can now just go ahead and open up that project and just launch the Scrum wall. So this looks like any normal Scrum wall. You have your backlog on the left, your sprint, your tasks and what you're currently doing. So we'll just go ahead and create a couple of new stories. We can then go in and edit those stories by double clicking on them, and we can enter some text as to what this user story is about. We can then just tick to save that. And we can then just go and edit the second story as well and put something in there. What we now want to do is we want to take those stories out of our backlog and put them onto the sprint that we're currently working on. So we just literally pick them up and drop them into the sprint. We can drop the second one as well. At this point we can open those stories up again, and we can actually assign which user is going to be working on them and the technical complexity associated with each one. There's only myself registered for this project, but you can obviously have multiple users as part of this. We've got our normal technical complexity scale, and we'll say this one is a 5. What we can also do, which is quite nice, is support inking. So if we went into the second story, for example, and opened that, we can then just move across to the inking tab, and we can now draw directly onto that story. So this is great if you've got a tablet or you're running off a smartboard. You can just write straight into it rather than having to type. Just save that. What we can now do is we can now add a couple of tasks associated to each one of those stories. And then we can drag them around. All quite basic stuff. When it starts to get really interesting though, is when we want to start to open this on multiple browsers and we can actually see the changes moving around between them. And now as we make changes on either of these two browser windows, we'll see the change immediately updated on the other window. There's a slight delay because this is running on Azure and we're going backwards and forwards across the Atlantic, but in a couple of seconds we should see that as now synced up to each other. So that, as a very high-level overview, is the application. And I'm now going to hand over to Marcus, who's going to show you a bit about how this application works behind the scenes.
Hi, so my name's Marcus Tillett. I'm Head of Technology at .NET Solutions. And I want to tell you a little bit more about the technology behind Scrumwall, and in particular how we migrated our on-premise version to Azure. So here at the bottom is our on-premise version that we built. Very simply sketched out here. So we have our browser-based Silverlight application hosted in the ASP.NET website, and that's served up to the browser. The Silverlight application here retrieves data through various WCF services, and that's all stored in a conventional SQL Server relational database. Now, the type of information we need to store is particularly user information, project information, and the notes associated with the project. So relatively simple, but there are some complexities in the way that information is stored. So when we look to migrate to an Azure platform, shown here at the top, some of the things were very simple. So we can translate our Silverlight application straight up into Azure, and we can still host it inside an ASP.NET website. That works very well. The more interesting area is over here in the way we store the data. So we had two choices when we went to Azure. We could use SQL data services, or we could use an Azure table store. Now, using SQL data services, the migration would have been very simple. But our data is actually very simple, and it fits the big table model very well, which is exactly what's supported by the Azure table store. So we decided to rebuild our data model completely. Now, this actually worked very well, because here we've actually got a number of DTO objects which are actually passed down to the browser and translated in our service layer, which means that we can still reuse the same data transfer objects, but just replace our data store. So, as I mentioned, there's a number of things we need to store. Most importantly, though, we need to store the notes that you have on a wall. The notes are relatively simple, but as you've seen, there are tasks associated with stories, so you've got some hierarchical relationship here. This is all stored, though, in one flat table. So the challenge here is that our service layer up here, as well as dealing with the data transfer objects, actually needs to repackage those based on the way the data is stored, so that it rehydrates this hierarchical nature of the data. So there was a little bit of extra effort here in our service layer, but besides that, it was relatively simple to actually migrate completely from a SQL relational data model to an Azure-based table store. The other challenging area was to do with configuration. So I've got a new box on here which is called configuration. So previously, when we were using an ASP.NET website, all of our configuration was hosted in the web.config. Now that's model certainly applicable with Azure, but it means you have to redeploy your application every time you want to make a configuration change. So with Azure, there's a configuration section which you can use, and certainly that's the recommended approach. And that works very well, and we migrated most of our configuration settings very easily. Some of the configuration associated here with our live ID logon and the controls associated with that were actually embedded to work only with a web application. So we actually had to wrap the live ID sections in our own custom code, and that way we could actually use the Azure configuration.
So anyone involved with software development knows that it's a never-ending process, and there's always new pieces of technology out that you can embed within your application, and we love to play with new technology, so we love to get new technology in there. Now at the moment, all of the message transport between our Silverlight application and our Windows Azure and our traditional on-premise application is based around the Meteor pattern. And the Meteor pattern effectively means we open up a connection from here to the web service, and we effectively say, wait until there's a new message arrived. When that new message has arrived, it then returns that back to the browser. So we can actually simulate push technology within the application, even though we're actually basing it on a HTTP poll-based mechanism. And that works quite well. It's what direct push uses on Windows mobile phones. But when you start to get up to thousands or hundreds of thousands of users, we're a little concerned that it might not cope with that. So one of the things we want to do is to start to use .NET services. So Marcus can tell us a bit more about how that works and how we want to embed it.
Absolutely. So the pattern we've got at the moment, as Dan says, works very well, but it is based on the number of threads that are available on a particular machine. And we've tried this up to 50 concurrent threads, and that's a reasonable number of users, and it works very well. But if we do want to get to the thousands of users for Scrumwall, and we certainly do, we need to look at what else is available. .NET Services is an excellent technology for this. This is all about moving messages around. So what happens is, again, the browser sends a message up to the service bus, and then any number of subscribers can subscribe to that message. So these messages are pushed down from the service bus directly to the browser. We don't need our middle layer here of services to manage this. We can completely replace that with the service bus. And this is very much on our roadmap.
And one of the other things that we want to do, of course, is to get Silverlight 3 support in there. We're looking at things like offline capabilities, so that if you're not actually connected to the internet, you can still bring up your Scrumwall and see what the current state of affairs is. So there's lots of things that we're currently working on. Watch this space.